we go into the third knowledge area, which is project time management. So project time management includes the process required to manage the timely completion of the project, scheduling at the task level and constantly monitoring the task completion. Okay, monitoring the task completion is part of the monitoring and control activity. Scheduling is the activity here in time management. First of all, you have to create that schedule. Generally, we use a MS Project, or sometimes even MS Excel is used to do the scheduling. Now remember, in this particular chapter, you will get quite a few questions, and there are some calculations associated with it, which we will see as we go forward. So the first step is your plan schedule management. You have to plan. So if remember, again, the schedule management plan goes into your project management plan. So the first step is to create the schedule management plan, that is how the schedule will be managed. Policies, procedures and documentation for managing the project schedule. So project management plan, charter, EEF and OPS are the inputs. Expert judgment, analytical techniques, meetings are your tools and technique. And schedule management plan is your output. So you have to decompose each of the work breakdown structure work packages to further detailed level in terms of activities. Now the decomposition has to come to a level where each activity should be done by only one person. It should not be that multiple people doing one particular work. So you have to break it down into that lowest level. So in IT industry, if you look at it, if it is a piece of code that you are writing, a piece of code cannot be written by two people for the same program, for the same objective. Hence, that is the lowest level. So you have to decompose it to this part. Rolling wave planning, again, as I said, we all have understood earlier in this activity definitions also. To the extent we know as of now on the work breakdown structures, the details we know, only that part we will decompose for the functionality that is being supposed to be delivered. Expert judgment is another tool. Output, activity list, activity attributes and milestone list. What is activity attributes? For each of the activities you have to put the different data, like we have to mention certain details, maybe like you can more in a non-IT environment it is required that you can have different attributes in terms of like progress, from where the resources will be taken, and you can have certain cost code associated with the activity, so that whenever the expense is being, whenever the resource is being utilized, you know how much cost has to be charged and so on and so forth. Now once you do the list down the activities, the next step is to sequence the activities. Sequencing activities means which activity has to be done after what. So there are some activities which will have relationships which are one after the other. Some may be done in parallel. So there are different types which we will have to see here. So schedule management plan, activity list, activity attributes, and milestone list. Milestones are actually activities with 0 days. That means milestones are actually the completion of a deliverable. It represents a completion of a deliverable. Project scope statement, EF and OPS. Now there are multiple tools and techniques. One tool is called precedence diagramming method or the PDM. Now this is a method by which we will create network diagrams and we will calculate various things. This is something which will be coming in your exam. At least 5 questions will be here. Dependency determination and leads and lags. We will understand all these concepts in today's session. And the output is your project schedule network diagram and the project document updates. This project schedule network diagram is what your project plan is, or the Gantt chart type thing. Now after activity lists are created, they need to be logically sequenced to identify the optimal duration of the project, identify the critical path and plan resource and materials of the project. So what is a critical path? What do you understand by critical path? Risk factors, no. Think in terms of something which is related to what we are talking now. Anything that hampers the scheduling? And broadly that is right, but what is a critical path? You are sequencing the activities and then finding the critical path. So what is it? Deliverables, no. Okay, so let me explain. Critical path is the list of activities which, if gets delayed, will delay the final completion of the project. That is a critical path. We'll see how to find that. So what happens is, as a project manager, it is not possible for you to look and monitor each and every activity that is happening in a project. In an IT project maybe yes, but in a project which has, even in an IT project which is a bigger project, there will be some thousands of activities. In a construction project or in a manufacturing industry, there are projects where the number of activities can go to 100,000s. Is it possible for the project manager to monitor each and every activity in details? It is not possible. So the project manager concentrates more on the activities on the critical path, because any one day of delay in any of the activity of the critical path will change the completion date of the project, end date of the project. But end date has already been communicated to the customer. That's the reason why you will like to maintain that. Sequencing of activities can be done using manually software like MS Project, Primavera, or it can be a blended approach. So project network diagrams are the most convenient representation of project activity sequencing. Now there can be three different types of dependencies. Mandatory dependencies. Mandatory dependencies means the logical relationship inherent in the set of activities, also called hard logic, which for example, you have to get the primer dry before you paint. That is a mandatory dependency. You have to boil the water before you can pour it to make your coffee. So those are mandatory dependencies. It has to happen in that sequence. There are some external dependencies like represents relationship between project and non-project activities. Like in a construction, you have to get your approval from municipality on your building plan before you can start your construction work. That is an external dependency. And then you have discretionary dependency. Dependencies which are defined by the project team or performing organization, also called preferred logic or soft logic. These dependencies need documentation as they may impact scheduling options later on in the project. Okay. So there are 4 types of dependencies which can be mentioned. One is a finish to start. That means one activity will finish, then only the other one will start. This is the most common one. This is called the finish to start activity. Then you have a start to start. Start to start, say for example, here it is given scrap the flecking paint off the house and prime the house. I would say a better example is generally when you are in construction, your electrical laying of electrical lines and laying of the plumbing lines are both done together, starts together, because once the house is constructed, the first thing is you start breaking those, creating those grooves in the wall for your concealed wiring as well as your concealed plumbing activity. Once that is, both are done, then only you can start putting the plaster. So that is something like you can have a start to start. Finish to finish, this is the most rare one. If I take the same example, in this case, the finish to finish means that 2 activities has to be complete for both the activities to be said to be complete. So on-site KT and offshore infrastructure setup both needs to be complete for your handover to take place. There is a question, we track our infra builds as a task, example check and validate UAT servers. Before our UAT starts in our PP, it is a good place to track dependency, converting them into tasks. Track our infra builds as task, example check and validate UAT servers. Before our UAT starts in our PP, is it a good place to track dependency, converting them into tasks? Actually, it should be tasks like UAT server checking for readiness of UAT servers is something which you have to do. Once you certify that, then you will put whatever needs to be put in on those servers for UAT to start. So those are all activities which needs to be performed one after the other. And then you have a start to finish. So testing lab is available only when setup of our automation tools are complete. Now start to finish can be handled by a finish to start also. So it's also not very common. We need to understand these concepts called lead and lags. So the leads and lags are represented to connote the delays or leads between two activity. There is a lead time, there is a lag time. Lead time is the overlap between tasks that have a dependency. So for example, you have requirements document preparation, and then you have design document preparation. Now requirements document preparation takes 1 month. Design document preparation takes another 2 months. Now requirements document preparation to design document preparation, you can put a finish to start relationship. That is only when requirements document preparation is complete, then you start your design. However, in practical life, that is not how it is. What we do is we say that, okay, after 1 week of requirements being done, start your designing process. So what we are doing is we are giving a 1 week of lead time. So that is a lead time. And lag time, the delay between tasks that have a dependency. Delay between tasks that have a dependency. So there are 2 tasks, but you have to wait. As I said, say if there is some concrete being done, after the concrete is done, you can start off with the next activity, like putting plaster, building your walls. Once you concrete the floor, but it is not right. What you have to do is, after the concrete is done, there needs to be a time when the concrete has to be cured by putting water. So you say that after concrete you need to wait for 30 days of curing to start off with laying the walls. So that is the lag time, the number of days that you need to wait for the next activity to start. So understand this lead and lag time. So estimate activity resource is this activity. This particular process is to estimate the type and quantities of material, human resource, equipment or supplies are required. So once you have got the list of activities, then what you have is the dependencies between those activities to define what is the duration of the project. After that, you need to assign resources in terms of man, material and machine, because it is with this set of resources, based on their resource calendar availability, is what will give you the actual estimation as well as the actual start and end date of your project. And this will also allow you to find out your cost of the project. So schedule management plan, activity list, attributes, resource calendar, risk register, activity cost estimate, EF and OPS are your inputs. Tools and techniques, expert judgment, alternative analysis, published estimating data, bottom-up estimating, project management software. These are your tools and techniques. And what is the output of this? Output of this is the activity resource requirement. So through this you know that from which date to which date you need which specific resource and for how long, resource breakdown structure and the project document update. Now resource breakdown structure is basically a document which shows the reporting relationship of the different team members within the project. Resource breakdown structure is different from organization breakdown structure. Organization breakdown structure is the reporting relationship as per the organization's organization chart. Resource breakdown structure is basically with respect to your project. A small IT project doesn't need much of a thing. Maximum you will have is some people reporting to the project lead, some people reporting to the project manager, and the project lead reporting to the project manager. But in construction and all, there are multiple leaders, each one leading a particular area like construction, design, design in the sense drawings. Somebody may be leading the plumbing, somebody may be leading the electricals. So there are different leaders and many people working under them. The next step is you have to estimate the activity duration. So now you have the list of the activities, you have the dependencies, you have the resources allocated. Now you have to estimate that how long will it take for each activity to do. So schedule management plan, activity list, activity attributes, activity resource requirements, resource calendars, project scope statement, risk register, RBS, EF and OPA are the inputs. Expert judgment, analogous estimating, parametric estimating, 3-point estimates, group decision making techniques, and reserve analysis are your tools. Your output is your activity duration estimate and the project document update. We will see what each of these are: analogous, parametric, etc. Now, what is analogous estimation? I have done similar project earlier, and that similar project took me 12 man-months. So this project will also take me 12 man-months. When you use past data, past historic data for similar projects to estimate, that is when you do analogous estimation. See, estimation anywhere is related to past historic data. Okay. So whether you are using a WBS, whether you are using a function point, it requires you to have some guess or some data. The more data you have, the more efficient is your, or correct or accurate is your estimation. So when I am taking the example, let's say, of the function point, and I calculate as per the function point calculation that this particular project will take me 150 function points. Now this project is going to be delivered using Java. Now if that is the case, and if you are saying that 150 function points on Java, how long will it take? Now there are multiple ways of doing it. One is that, okay, I know that generally similar situation earlier in the project, what I have done is it took me around 8 days to 10 days for this Java per function point kind of an activity. Now if one function point is taking 8 days, so 150 function points will take 150 into 8, so 1200 days. Now this, how do you get that? So when you start first time in an organization, generally what you will do is you will use a guesswork from your experience. But as you start using a project management process, you are going to start putting these values, how you calculated in each of the project in your project management information system. So next time when you come out, when you have to estimate, you will actually take the data from the previous estimates that has happened, and there you will also see that when you had initially maybe you have thought of 8 days or 10 days, but after the project was done you saw that 150 function points required not 8 or 10 days, but it actually required say 9 days or say 7 days. So then you can use that. For function point, one of the advantage is that in the market also you can buy data which is across like some thousands of projects, data is being captured and is being sold, so that you know you can use those also as your calculation. Now all of these, basically what we are talking about is analogous estimation, where you are using the past data of similar project. Okay. Now in case of WBS also it is the same thing. First of all, you define what is a low, high, medium, low, or a simple, medium, complex kind of classification. Then you will take the activity and you will say that whether that activity is high, medium, low, or small, medium, large. And then based on your understanding or experience you will say that okay, small will take 2 hours or 2 days, medium will take 4 days, and high or large will take 8 days. Now then as you start getting knowledge of more and more projects, you will refine that figure and use that. Now analogous estimation is only when you are straight away taking whatever your past experiences and using that. So I am today doing whatever the project I am doing today, I know similar project I have done, so that I took 1 man year. This project also I will take 1 man year. That is expert judgment, analogous estimation. Parametric estimation is similar, but remember that parametric estimation requires you to have some calculation with it. So either you can take past data and you have to put some figure. So on a simplest manner you can say that okay, in my past experience in that project I have taken it 1 man year. But the current project I feel that we have done many more projects on this and we are more efficient, so we will be able to do it in 10% less time. So then you use that 10% and you give a lesser time. Or if you feel that this project is a bit more complex than what you had done earlier, so you need 25% more time. So instead of 1 man year you will put more than 25% more. Okay, so that is one way. The analogous is parametric is any time when you feel that when you see that the question is talking about past data with some calculation, it is parametric. Or it can be something like this. You have calculated earlier in construction like how much time it takes for excavating 1000 cubic meter of earth. So now if you have 10,000 cubic meter of earth to be excavated, you exactly know how much it is. Similar, so those are kind of calculations which you use for parametric estimation. Now there is another estimation called 3-point estimation. 3-point estimation is basically what is also known as PERT estimation, P-E-R-T, PERT estimation. So what I have done is, if I had asked, or if you ask anyone that what is the time you will take to write this program, the person will say a particular value. But if you ask the person on what is the maximum time you will take, what is the minimum time you will take, and what is the most likely time you will take, you will get three values. Now there is a particular formula in PERT. The formula is optimistic plus 4 times most likely plus pessimistic whole divide by 6. So in this particular case, it is 120 plus 15 plus 4 times 45 minutes. So how much does it come to? 120 plus 4 times 45, 160 plus 20, 180 and 15. So that is your 315 minutes. Now that 315 minutes divided by 6 is around 53 minutes. So in this particular case, you will roughly take 53 minutes as your time, and you will be most of the time accurate with your estimation for reaching your office within the time. So roughly around, if you take 53 minutes before you have the time that you have to reach office, if you take 53 minutes early, if you leave your home, you will be reaching your office most of the time in the right time. So for accuracy also it is the same concept. Now one of the things, who does estimation? Who is responsible for estimation? Anjali says PM. What about others? What about others? Do you feel the same? Satyan says team. For your examination purpose, even for in Agile and everywhere, you will see that it is the team who should be doing the estimation. If the project manager is doing the estimation, then the buy-in of the team is not there. If the team says what they will take, the buy-in of the team is much higher. So estimation is not done by the project manager, it is actually done by the project team. In practice, most probably we always see that the project manager quickly creates a project plan and gives it. So the estimation is done by the project manager. It is not right as per PMBOK. PMI expects that it is the team who will be doing the estimation. So if you look at 3-point estimation, to mitigate the risk on estimation, project manager uses 3-point estimate. A 3-point estimate requires that for each activity an optimistic, most likely and pessimistic estimate to be created. Based on these 3 estimates, an average can be created to predict how long the activity should take. 3-point estimate is the new name for PERT, or Program Evaluation Review Technique. Okay. Now, just for your understanding, let me tell you that in PERT, you can also get question along with PERT using standard deviation. I will show you a couple of examples later on at the end of the course, but questions come with standard deviation calculations. So you need to know standard deviation and talk about the formulas also. Once you have the estimation, the resource, the activity, the dependencies, now you are ready to create the schedule. That is what we loosely call project plan in our Microsoft project. That is a project schedule. So schedule development is the process where we will create this schedule. Schedule management plan, activity list, activity attributes, project schedule network diagram, activity resource requirement, resource calendar, activity duration estimate, project scope, statement, risk register, project staff's assignment, RBS, EF and OPS are your inputs. So there is a huge list of inputs here. Tools and techniques, schedule network analysis, critical path, critical chain, resource optimization techniques, modeling techniques, crashing and fast tracking, schedule compression and scheduling tool. All these we will be using for tools and techniques. Scheduling tool is easy. Scheduling tool is like Primavera or MS Project. Schedule compression, crashing and fast tracking we will see today itself. Modeling techniques also we'll see. Resource optimization technique, critical chain, critical method, critical path we will see. So the output is a schedule baseline. So once you get the schedule, once that gets approved, you have to baseline that schedule. And project schedule, schedule data, project calendars, project management plan update and project document updates are your outputs. So you can have outputs like milestone chart, bar chart or a network diagram. So if you look at the screen, this project schedule and network diagram, this is a network diagram. So we'll be using network diagram to do some calculations.